To introduce you to what we term instrument in our laboratory. We need to have equipment and instrument. There are differences between equipment and instrument. That the instrument you can constantly come in contact with whenever you come to the laboratory is what I'm going to introduce to you. This is what we refer to as panel meter, and it is analog in nature. It's a DC voltage meter. If you look at the ranges here, it started from 3 volts up to 300 volts range. Even though we rarely use the 300 volt aspect, what we normally use is that of 3 volt, 10 volt, and 30 volt, as the case may be. Now, most of our students usually run into problems, especially during the practical exam. Anytime they are given this type of instrument, we ask them to use it to read the measurement. Problem normally arise. Now look at it now. If you look at this screen, you can see 2 ranges. The upper range is 0 to 10. Whereas the lower range is 0 to 30. Now, if the manual asks you to use 0 to 3 volt range, and this one is pointing to 3, what you are telling this instrument to read is between 0 and 3 volts. But if you come here, you can see 0 to 10 and 0 to 30. How do you do it to convert this into 0 to 3 volts? So what must first come to your mind is that you look at it. Which one will be easier? Will it be easy to convert 0 to 10 to 3 volts or 0 to 30? Naturally, one will expect to use 0 to 30. So whatever you get there, when you use the lower range, lower scale, whatever reading you get, you just divide by 10. That one will convert it to 30. Because if you divide 30 by 10, what will it give you? Is it not 3 volts? 3 volts. Now, if you connect this into the circuit, and the pointer just right from here and rest at 10 here, when you get to 10 here, at the back of your mind, since you know that you are going to divide whatever you get there by 10 to convert this to 3 volts, then this 10 here will now mean just 1 volt. So if it goes to up to 20, that 20 will just be 2 volts. And vis-a-vis when you get to 30, that is 3 volts. That's exactly how to use it without any wahala. Now, even the manual now asks you to use 0 to 10 volts, then you don't have any problem. You just use the upper scale. Because if this is 0, this is 1, this is 2, up to 10. Finally, if you are being asked to use 0 to 30 volt range, because there's no way you will not use any of these, either 3, either 10, either 30, then you just use the lower scale direct without any problem. That is about how to use this one. No problem. Another one, which is very scary, is this one. And there is nothing much in it. It's only the student normally, I don't know what normally may happen to them anytime you are given this type of meter to read. It's also a panel meter, but it is a dual panel meter. That is, it can be used to measure the voltage as well as current. When you just follow the procedure or how to go about it, then you won't have any problem. For example, that of DC voltage reading, this side is just exactly what you are having here. But anytime you now want students to use this as an ammeter, that is where we normally have problem. Now, there's no problem at all. Anytime you are given this type to use, what must first come to your mind is to come to the left hand knob. Wherever position you may find it, just vary it to DCA. It is then you are now telling this instrument, hey, I want you to read current for me, not just voltage anymore. So once you put it here, and you have your connecting wire connected here, it will just be looking at you, it will never work. Now, if anytime I want to measure current, once you set it into DCA, you will now come here to make use of the ranges, as it were. The manual automatically will guide you where to set the range. It's not you that will choose that one by yourself. Now, you can see that this is 0.1 milliamp. Don't mind the manufacturer. You can see that they use big M instead of small m. It is not mega amp. There's nothing like that. It's still milliamp. You will see, you agree with me that once you have this thing as 0.1 milliamp, it simply means from here to here is now 0.1 of a milliamp. Now, here you can see 0 to 10. How do we now convert 0 to 10 to 0.1 milliamp? What must first come to the mind of any student is to use the upper scale, and you divide that one by 100. You know, if you divide 10 by 100, what will it give you? That is 0.1. That is to say, the full scale deflection, FSD, is now 1. When you set this thing on 0.1 milliamp, it's now 0.1. But what you need to do is just to make sure that whatever reading you get here, anytime you select this range, you just divide by 100. For example, if the pointer just rise from here, from 0 here, and rest on 2, what will now be the answer? The answer will definitely be 0.02 milliamp. That is exactly how to make use of that. No problem. Another time, the manual might say, set the milliamp range of your millimeter to 1 milliamp range. Once you are on 1 milliamp range, then you still continue to use the upper scale. If we have our way, Gary, we don't even want you to use this analog thing. Had it been that we have plenty money to buy everything analog, digital. But since we don't have that one, we still continue to use it, and there's nothing even bad in that. All what we've been using before with the invention of this digital, you can still go ahead and know about it. That is another important thing to note. Now, since this thing is on 1 milliamp range, then you still use the upper scale. What do we do then? You use the upper scale, whatever reading you get, you just divide by 10. If you divide 10 by 10, what will it give you? It just give you 1 milliamp. That is to say, if the pointer rests on 2 as before, what will now be the answer? The answer will just be 0.2 milliamp. That is 0.2 times 10 raised to power minus 3 ampere. That is it. That is exactly how to use that. No more, no less. When you follow all these things, I don't think you will have any problem in using this type of dual meter. Now, another time, the manual might say, I want you to use 0 to 10 milliamp. Then you vary this thing to 10 milliamp, pointing to 10 milliamp range. So that one is very, very easy. You don't need to crack your brain. Whatever reading you get, you use the upper scale. No more, no less. Here, at times, the manual might say, it's right inside the manual, where if you have to use 0 to 100 milliamp. But you now use 0 to 100 milliamp. What will you do? So what I expect you to do in this one is to still use the upper scale. Whatever reading you get there, you just multiply by 10. If you multiply 10 by 10, what will it give you? 10 times 10 is 100 of a milliamp. Don't forget, I told you before that this is not mega amp, it's milliamp. It's supposed to be written in small m. That is it. So if the pointer rests on 6, when it's on 100 milliamp, so your answer definitely will be 60 milliamp. Finally, that of 0 to 1 ampere range. So that 1 ampere range, you just still use the upper scale. Whatever you get there, the reading you get, you still divide by 10, but you get the answer in ampere. no more, no less. That is exactly. We rarely use 3 ampere in this laboratory, and if you are to use it, you just use the lower scale and divide by 10. Then these are the digital multimeter. Digital, all these one are the analog, but this is digital. Digital multimeter, that is what we call it, multimeter. It can be used to measure resistance. You can use it to measure DC voltage, AC voltage, DC current, AC current. It can measure frequency. It can measure temperature, as well as the capacitance of any capacitor. Very, very useful thing. Now, to use this type of thing, to power this digital multimeter, there is an on and off button from here. And if you get a certain voltage and you want it to hold, you can press this one. But we don't even really need this one now. I told you before that this instrument can measure most values, that is resistance, capacitance, inductance, and what have you. Now, if you want to use it on ohmic range, like I said before, if you select 200 ohms range, you can see it will just give you 1 if you have not engaged the probe. This is the probe, positive terminal and negative terminal. If you did not engage the probe, it will just give you 1. That one means infinite resistance. But if you allow it to touch, it's supposed to give values. Try to measure the resistance of the cable itself, not any other measurement. So in the normal, something is supposed to give you around 0 or thereabout. But maybe because of the battery inside is not all that working perfect. That's why you are seeing this as high as 30. Or maybe the resistance of this one is almost close to that one. Now, if you want to measure anything, like I said, any range between 0 and 200 ohms of a resistance value, you select this one. Anytime you select anything greater than 200 and you select this range, it will never work. It will just give you 1 as well. So if you want to measure anything greater than that, you just select 2K. That is 2 kilo ohm. So the next one is 20 kilo ohm until you get to 200 megohm. That is 210 raised to power 6 ohms. That is exactly how to use this one to measure resistance. It's digital because you don't need to crack your brain to do any calculation. It will just give you the value straight. That is it for that one. Now, if you want to measure DC voltage, you come here. You vary the knob to this because this is the symbol for DC voltage. So you just vary it to this point. The minimum it can go is 200 millivolts, followed by 2 volts, 20 volts, until you get to 1000 volts DC. That is it. So for that of the AC voltage as well, you can come down, you can see it. Just the maximum this one can go is 750 volts, which means you can even use this one to measure what is coming out from the power supply. The one you are using, that is the AC voltage that we have connected our power supply onto. So that is it. Then the next one is 200 volts, 20 volts, up to the minimum of 2 volt range. So that is that. We don't really need to use the other range here, like temperature. This one has gone beyond the scope of what we are going to teach you in this laboratory. So temperature, frequency, and what have you. Then we don't normally encourage our students to use it as this digital multimeter as millimeter, because we are afraid maybe the student can just damage it. But if we closely monitor you, you can still make use of it. For example, if you want to measure DC current, then you have to move this probe from here and connect here to this milliamp ring. that's the only time it's ready to measure current for you. This command is stationary. You don't need to touch this one. So you will now be using this one and this one. Unlike when you are measuring voltage, resistance, and what have you, you have this probe being connected here for the measurement. You can even see from here. You can see for voltage, temperature, ohms, diode measurement. You have to get into that one in the course of this practical. We are still going to do, use this all other things like a diode and what have you, but the frequency, we don't really need it here. So for that of current measurement, you just put it here. Or you want to measure capacitance of a capacitor, you use all this and this for that one. So like this one now, the minimum, if you want to use it to measure current, DC current, for that matter, the minimum is 2 milliamp. Next is 20 milliamp range. The manner we guide you have to set it anyway. Then the another one is 200 milliamp. And then you only need to redirect. You don't need to do any calculation from your head. No. Or like when you are using analog meter, you still need to do multiplication, you divide, you do all sorts of things. But this one, that is the advantage digital multimeter has over analog multimeter. That is that. So the next one, which I want to really show you, is this meter. It is also digital multimeter, but it is auto range. Look at this one. The other one, we are using this thing to set it to the various ranges. But this one, you just select. If you want to measure DC, you just select DC. Then it will do the calculation by itself and just give you the value, and you write the value down. Even if it is the resistance you want to measure, just select this ohmic symbol. When you select the ohmic symbol, if the meter did not allow if the probe did not touch one another, it will just give you OA. Just unlike one, the other one gave to you. So if you now allow it to engage, just like the other one, you will see, trying to measure the resistance of the cable we are having there. So also, if it is a resistor you want to measure, you just apply it across the resistor. If you want to measure diode, you want to know the effectiveness of any rectifier diode, which we are going to deal with that one extensively later in the course of this practical. You just select here, and so on and so forth. If it is for the current, like I told you, just come to current symbol here, milliamp. Then at that time, you have to change this one just like before. You remove it from this ohmic, voltage, and capacitance knob socket here, and then connect it here. That is exactly how to use it. And the advantage of this one is that instead of when you are using this one, you are selecting the range by yourself. This is auto ranger. Once you just select the one what you want to measure, whether DC or AC or capacitor or current, whatever, you just select it and then it's ready to take the reading for you. Thank you.